This is a video on slope and writing linear equations, lesson 3-3. In this lesson, you will understand the slope of a line and how to calculate it using 2 points on a line, either from our graph or from given points. You'll be able to write a linear equation using point-slope form and slope-intercept form when given 2 points, and you can identify the slope and x and y intercepts of linear equations. A linear equation is an equation whose graph is a line. So when we graph it, it's going to be straight. The most common form that we use to write a linear equation is y equals mx plus b. The y represents every y value on the line. The m represents the slope, which is rise over run, and b represents the y-intercept, which is where the line crosses the y-axis. So if we want to write a linear equation given slope and y-intercept, here's what we'll do. The first thing we'll do is we'll substitute the slope that we're given for m and substitute the y-intercept for b, and then we'll write our equation. So here's an example. Let's say, for instance, our slope, our m, is 1/3. Our y-intercept is 17. Well, then our equation would be y equals 1/3 x plus 17. We're substituting into y equals mx plus b, right? Y equals mx plus b. On some occasions, you may be given slope and a point. And in this case, you'll need to use what's called point-slope form. So the first thing we would do is we would use the slope in one of the points, and we would plug into point-slope form for m, x1, and y1. Now, point-slope form, as you can see here, is y minus y1. This is what we're going to substitute the y value from our point, equals m, which is our slope, and then in parentheses we have x minus x1, and x1 is the x value of the point that we're given. And then we will distribute to eliminate the parentheses, and then we'll add or subtract to isolate y, and we'll get our equation in slope-intercept form. Okay, let's do another example. Example 2, we're going to write the equation of a line with a slope of 3 passing through 1, 5. Okay, so m is our slope, so we'll plug in 3 for m, 1 for x1, and 5 for y1. So let's go ahead and do that. Y minus our y1 is 5 equals m, which is 3, times x minus 1. So we've done step 1. Now we're going to do step 2, which is distribute to eliminate our parentheses. 3 times x is 3x. 3 times -1 is -3. And now we must add or subtract to isolate y. So we will add 5 and add 5. And we end up with y equals 3x plus 2. And that's our solution for example 2. In the next example, we are given a slope of -5/6. That's going to be our m. And the point 2, -2. 2 is x1, -2 would be y1. And using the slope in one of the points, we're going to plug into y minus y1 is -2, so we make that a plus, equals -5/6 times x minus x1, which is -2. So now we're just going to distribute. -5/6 times x is -5/6x, and -5/6 times -2 will give us plus 10/6, which simplifies to 5/3. Alright, so now that we have that, we want to get y by itself, so we're going to subtract 2 from each side. I know that 2 whole is 6 thirds. So we're going to do minus 6 thirds. So our final answer would be y equals negative 5/6 x minus 1/3. Notice that I left my y-intercept as a fraction. Do not put decimals rounded. Okay. Sometimes you may need to write a linear equation given 2 points, but you are not given the slope, so you have to find it. In this instance, the first thing you'll do is you will find the slope using our slope formula that you see here. So we would just say y2 minus y1 over x2 minus x1, and we find the slope first. And then we use the same process we used before, where we plug into point slope form. The only thing is now you have 2 points, so you just choose 1 point and then follow through with the rest of the steps. Okay, so let's try some of those examples. So let's look at this example. We have a line passing through the point 0, 3 and negative 4, negative 1. And so first thing we want to do is find the slope. Remember, that's m equals y2 minus y1 over x2 minus x1. And we're going to substitute in x1, y1, x2, y2. So y2 is negative 1 minus 3, that's y1, over negative 4 minus 0. Okay, so we go ahead and simplify. Negative 1 minus 3, that's negative 4. Negative 4 minus 0 is also negative 4. Negative 4 divided by negative 4 is 1. So our slope is 1. Now we're going to substitute in. We only need 1 point for point slope form. So I'm going to use the first one because that one will be easier, I think, to do. All right, so we'll do y minus 3, that's our y1, equals 1 times x minus 0. Okay, x minus 0 is just x. So now we have y minus 3 equals x. And if I distribute 1 here, that's 0 for the 1 times 0 is 0. We're not going to even write that. 1 times x is x. So now we just have y minus 3 equals x. Add 3 to both sides, and we have y equals x plus 3. And that is our equation in slope-intercept form. In this next example, we are given 2 points. So we're going to find the slope first. We'll start by doing y2 minus y1, so that would be negative 3 plus 2. And then x2 minus x1, that would be negative 4 minus 5. So we get negative 1 over negative 9, and when we simplify that, we get 1/9. Now we're going to use this slope, and we'll use this point as our x1, y1 to plug into point slope form. So we have y plus 2, since it's minus negative 2, we'll make that plus, times 1/9 times x minus 5. We will go ahead and distribute our 1/9, and we get 5/9 here. And the last thing we want to do is subtract 2 from each side. And when we subtract 2 from each side, we get y equals 1/9 x. I know that 2 is 18/9, so I'm going to have to subtract 18/9 here, which gives us minus 23 over 9. And so now I have y equals 1/9 x minus 23 over 9, and I'm going to leave that in fraction form. And that is it for this example.